Hello, how dear my dear students, Namaste to all. Today I am giving you very interesting lecture about the Lassaigne test that is very important for knowledge as well as examination view of point. So what you see? Questions related to Lassaigne test. So what you see? Questions related to Lassaigne test. So that is very important for you knowledge as well as what you see examination view of points. So Lassaigne is a very famous chemist, J.L. Lassaigne in 1843 developed very cheap, effective method to detect foreign elements like nitrogen, sulfur and halogens present in organic compound. So this principle or this technique is used up till now. So that is very famous principle given by the Lassaigne, J.L. Lassaigne, which is very cheap, effective method to detect foreign elements. Foreign elements means those elements other than carbon, hydrogen, oxygen present in organic compounds are known as foreign elements like nitrogen, sulfur and halogen. Halogen means X, maybe chlorine, maybe bromine, maybe iodine. So I think so very useful what to say principle given by the what to say Lassaigne. So numerous questions are as follows. What to say? First one is question 1. What are foreign elements? Give suitable example. So foreign means other than. Answer of this question is other than, in short, other than maybe carbon, maybe hydrogen and oxygen atoms present in organic compound is known as foreign. That is also sometimes known as hetero elements. Thus, other than carbon, hydrogen and oxygen atoms present in organic compound is known as foreign elements. Yes. So example are like this. When talk about the example, so like this, nitrogen, I've already talked you, nitrogen, sulfur and halogen. Halogens means maybe X, maybe chlorine, maybe bromine, maybe iodine. I think you have clear what are the foreign elements. Give suitable example. So other than carbon, hydrogen and oxygen atoms present in organic compound is known as foreign elements. I think you have clear what are the foreign elements. Next question is, like this. What is sodium extract? So in short we can say YASE, sodium extract. What is sodium extract? Yes. So answer of this question is like this. So these all questions are very important for knowledge as well as examination viewpoint, we can say. So what we say, the sodium extract which is prepared by fusion of organic compounds with sodium metal is known as foreign, what is it? Sodium extract, known as sodium extract. You have clear? The extract generally we prepared in the lab by the fusion of organic compound with sodium metal is known as sodium extract. Yes. Next question is, third question is like this. Question is like this. Question 3. Why sodium extract is alkaline in nature? Alkaline in nature. So when you make the sodium extract in the lab, so in this case what we see, so answer is like this. Why sodium extract is alkaline in nature? So when you make the sodium extract in the lab, so what we see, not all the sodium metal used in reaction. Some of the sodium remaining over there. So we can say excess of sodium present in sodium extract reacts with water to give sodium hydroxide. You know, it is sodium hydroxide, you know, it is base. to hydroxide, so it is alkaline in nature. So why sodium extract is alkaline in nature? Because excess of sodium, not all the sodium used in the experiment. So sodium reacts with water, and what we get? Sodium hydroxide plus hydrogen gas. What is 2 hydrogen over here? So what we have? 2Na, 2NaOH. How many oxygen? 2. Yes. So due to formation of sodium hydroxide, it is alkaline in nature. I think you have clear why sodium extract is alkaline in nature. Fourth question is like this. Write the principle of Lassaigne, name of chemist. Write the principle of Lassaigne. Give its usage. Yes. Write the principle of Lassaigne. So we have already studied about the organic compound. Organic compounds are generally covalent in nature, and when they are covalent in nature, so they are generally insoluble in water. If they are insoluble in water, we cannot do any test of nitrogen, sulfur and halogen. So what we have to do? We have to make organic compound. We have to fuse organic compound with sodium metal. Why? To get the ionic compounds, and which are soluble in water, and we can perform different type of test. So what we see? Write the principle. What the principle of this one? Organic, generally no. Organic compounds are generally covalent in nature. So it is insoluble in water. Yes. To make soluble in water, organic compounds are fused with sodium metal to give ionic compounds, which are soluble in water and able to detect foreign elements. Foreign elements means other than carbon, hydrogen, oxygen, like nitrogen, sulfur and halogen. They are known as foreign elements. So I think you have what the principle. This principle was given by Lassaigne in 1843. So that is very old, but this principle is used up till now. So that is very famous, very useful, very effective principle. to get the taste of different type of foreign elements. So what write the principle of Lassaigne? Principle of Lassaigne test, better to say Lassaigne test. Give its uses. Uses, you know, it is used to detect different type of foreign elements in ionic states, like ionic compounds are as follows. So what you see, generally what we have to fuse with sodium. I know it's very reactive. So sodium react with carbon. Carbon present in organic compound. Nitrogen is also present in organic compound. So what we have? So what we get? Sodium cyanide. Na positive charge, negative charge. That is sodium cyanide. That is what you see, ionic compound and soluble in water. Suppose organic compound sulfur. So when fused with sodium, so what we have? Na. So what you see, sodium positive charge, negative. That is known as sodium sulfite. So what you see, two over there. So sodium sulfite. Likewise, when you talk about the Na plus halogen, X means maybe chlorine, maybe bromine, maybe iodine. So what do we have? NaX. X means halide, and maybe chloride, maybe bromide, maybe iodide. Sometimes what you see, it contains what you say, sodium, carbon, nitrogen plus sulfur. These all comes from the what you say, organic compounds. They are present in organic compounds. So at that time what we have? Sodium, that is known as sodium thiocyanide. That is known as sodium thiocyanide. So we get different types of ionic compounds. First, sodium react with carbon, nitrogen, that come from the organic compounds. And what we have? Sodium sulfide. If sometimes organic compound sulfur, so what we get? Sodium sulfide. If sometimes contain X means halogen, maybe chlorine, bromine and iodine. So what do we have? Sodium halide. That is X having negative charge. What do we? Maybe chloride, maybe bromide, maybe iodide. Yes, why we have clear. So when we talk about the principle of Lassaigne test, so in this case we get different type of ionic compounds, and these all are soluble in water and do the test easily. Yes. Next one is first detection of nitrogen foreign elements in given organic first detection of nitrogen in given organic compounds. For this, always what we have to prepare? Sodium extract. Yes, and from this sodium extract, what we have to do? We have to do different type of test. So what do you say? For detection of nitrogen in given organic compounds, what do you see in this case? What do we take over here? So what do you see? When sodium extract maybe what's the 1 2 ml 1 2 ml is reacted with sodium hydroxide solution, reacted with what is sodium hydroxide, which is further reacted with freshly means freshly, you know, freshly prepared ferrous sulfate, that is ferrous sulfate solution, green precipitation, short we can say PPT, green precipitation is obtained, which is reacted with means which is boiled, cooled in tap water, then added few cc, what to say, added 1 dilute, better to say dilute HCl, dilutor, what is the conch, dilute means you know what is mixed with water, conch means concentrated hydrochloric acid, and at last added few drops of ferric chloride solution, we get Prussian blue or green colored compound, green colored solution, better to say green colored solution due to formation of ferrocyanide complex compound, it shows presence of nitrogen. So this question is generally asked in 5 marks. So very, very important for you. So it shows presence of nitrogen. Sometimes ask you write down how can you prepare or how can you detect nitrogen in sodium extract. Sometimes ask you write down only the reaction involved during the test of nitrogen. So now we have to see different type of reaction. So what the reaction over here? So at first, Na, you know, I have already told you in what you see principle. At first, sodium fused with organic compound, it may contain carbon, nitrogen. So what we have? Sodium cyanide, what you see, ionic compound. And also, you know, excess of sodium react with water. So what you get? Sodium hydroxide plus hydrogen gas. So what is it? 2Na, 2H2O, 2NaS. Yes, H2 gas. Now this what you see NaCN. So what you see NaOH. Now we have used ferrous sulfate in this case. So that ferrous sulfate react with sodium hydroxide to give what we have? Ferrous hydroxide. I have already told you in reaction. So this is green PPT. That is green PPT plus what we get? Sodium sulfate. That is sodium sulfate. So how many sodium? 2. Ferrous hydroxide, 2NaO, ferrous sulfate. So what is the one sulfate? So that is green PPT. After the formation of green PPT, what we have? So that react with sodium cyanide, one of the product over here. So what we get? FeCN2, ferrous cyanide plus sodium hydroxide. Yes, that is ferrous cyanide. How many CN? 2. Yes. So ferrous cyanide. Now this ferrous cyanide, react with what is the ferric chloride solution. So what to get? Na4 FeCN6, that is known as sodium ferrocyanide. Now this sodium ferrocyanide react with ferrocyanide. What to say? Excess. So what to get? Na4 FeCN6, that is sodium ferrocyanide. Now this sodium ferrocyanide react with ferric chloride solution. So what to get at last? At last what to get? Ferro, Fe, that is known as ferric, ferro, and side product is what we see? NaCl. And due to formation of ferrocyanide, what we get? Prussian blue. Sometimes what is the green colored solution, not PPT. In PPT, what you see in trans, may I ask you, so Prussian ferrocyanide is what is solution or PPT? Then what we have answer? Prussian blue. Prussian blue means color in between blue and green is known as Prussian blue. Sometimes what you get? Prussian blue. Sometimes what you get? Green color. It shows presence of nitrogen. So if you ask in 5 mark, then we have to write the language. then you have to give all the reaction. Yes. I sometimes ask you what the reaction, write down the reaction involved during the test of what you say nitrogen. So balance questions, what you see. Three, 4 FeCl3, what you get, ferric 12 NaCl. Yes. So you can sometimes ask you 3 questions from this one. First, how can you detect nitrogen in the given organic compound? First question. Second, write the reaction involved during the test of nitrogen in organic compound. Yes. Sometimes ask you, in this case also we used words HCl and conc HCl. Question arises, why we use? Question is like this, why we use dilute HCl or conc HCl. If dilute, then what we have to use? In excess. If conc, we use very low amount. Conc HCl is used during the test of nitrogen. Yes. So what the answer of this question? Sometimes you ask you, maybe in Viva, sometimes also your Viva in practical. In practical also we have some question like this. So what do you see? Why you use HCl? It is used to dissolve excess of ferrous hydroxide, to dissolve excess of ferrous hydroxide present in the reaction. So you have clear why. So what do you say? Ferrous hydroxide that react with dilute HCl, hydrochloric acid. So what do you get? FeCl2 plus H2. That is ferrous chloride. Yes, ferrous chloride. So that is what the color of this one? Green. Excess. If what is ferrous hydroxide present in the solution, excess, then what we have to do? We have to treat with dilute HCl, and what do we get? Ferrous chloride. That is soluble in water. 2Cl2, 2HCl. Yes. CH2, 2H, 4H. So what we have to do? 2H, 2H. You know, I have already learned about the so many reaction, how to balance the chemical equation, how to write the molecular formula. I have so many technique about how to balance the chemical equation. So we have to see all these. Yes, that I thank you. So thank you all for watching this video, and I think you have already described or subscribe and also convey channel to your friends for learning.